Okay, let us begin with this length of polar tangent, polar subtangent, polar normal, and polar subnormal. I have drafted this figure. This is PR theta. This is the tangent. This is the normal. This is the line which is perpendicular to the radius vector, meters the normal at n and tangent at t. Let us see from this. From this, there was a confusion with regard to the triangle. Now let me take this triangle OPT or TPO. You see, from this triangle you can see what is cos of phi. Base by hypotenuse. Base is OP and hypotenuse is PT. This is R by PT. So your PT is R by cos phi. It is R secant phi. So this is R secant is 1 plus tan square phi. Tan phi, you know, this is R d theta by dr whole square. So this is R 1 plus R square d theta by dr whole square. This is length of the polar tangent. Now I can have from this triangle again tan phi. What is tan phi? Perpendicular by base. OT by OP. It is OT by R. So your OT is equal to R tan phi. But you know what is tan phi? It is R d theta by dr. So this is R square d theta by dr. So length of polar subtangent is R square d theta by dr. Length of polar tangent is R under root of 1 plus R d theta by dr whole square, or this one. Again, from the triangle OPN, above triangle, this triangle, what is tan 90 minus phi? Yes, perpendicular by base, ON by OP. This is ON by R. But tan 90 minus phi is what? It is cot phi. ON by R. So ON is equal to R cot phi. Or this is R by tan phi. But you know what is tan phi? It is R d theta by dr. R cancels out. So ON, length of polar subnormal. ON, length of polar subnormal is actually dr by d theta. Similarly, we can have, I have found tan and cos. I will find cos of 90 minus phi. Base by hypotenuse. OP by PN or NP. OP by PN. R by PN. But what is cos 90 minus phi? It is sine R by Pn. This gives us Pn is equal to R by sine phi, which is R cosecant phi. But cosecant phi is 1 plus cot square phi. So this is R 1 plus cot phi is 1 upon tan square phi. So this is R tan phi is R d theta by dr. So this is 1 plus 1 by R square or 1 by R dr by d theta whole square. This is R, polar tangent and polar normal. This is R 1 plus R d theta by d whole square. This is R 1 plus 1 by R dr by d theta whole square. Length of polar subtangent is r square d theta by dr, but length of polar subnormal is dr by d theta only. So this is length of polar normal. Fine. Let me take one more article, that is relation between P and R, known as the pedal equation. Pedal equation. A relation between P and R. What is P and what is R? R you already know. See, if this is the curve R equal to f theta, this is the point PR theta. This is tangent to the curve at this point. This is the pole. This is R. You know, this is phi, angle between radius vector and tangent. Let me draw a line which is perpendicular to this tangent. Perpendicular. That length is denoted by P. This is not the initial axis. You see, if I will take a curve like this is r equal to f theta. This is the tangent to the curve. This is the pole. This is the point PR theta. This is angle between tangent and radius vector. This is initial axis. See, this is initial axis. What I am doing this, I am drawing a perpendicular from the pole upon the tangent. This is P. Say this is P L. P L. O L. O L is P. So I have to find relation between P and R. That relation is known as pedal equation. You see from this, what is sine phi from this triangle? From the triangle OPL. Sine phi perpendicular by hypotenuse. OL by hypotenuse is OP. So sine phi is OL is P, OP is R. So P is equal to R sine phi. This is known as pedal equation. This is the pedal equation. Relation between P and R is known as the pedal equation, right? We can also write it as 1 upon P is equal to 1 upon R sine phi. This is another notation. 1 upon P is equal to 1 upon R sine phi, or 1 upon P square is 1 upon R square sine square phi, or this is 1 upon R square cosecant square phi. But you know cosecant square phi is 1 plus cot square phi. Again you know cot square phi is 1 upon tan square phi. So this is 1 upon R square, 1 plus 1 upon R d theta by dr whole square, because tan phi is R d theta by dr, dr d theta by dr. This is 1 upon R square. Again, this is 1 plus 1 upon R square dr by d theta whole square. Or your 1 by P square is 1 upon R square plus 1 by R4 dr by d theta whole square. This is again a pedal equation, relation between P and R. Fine. Let me come to the exercises. Examples. Let me first see few prerequisites are there which I need. You know, tangent of pi minus theta. What is that? It is minus tan theta. tangent of 90 minus theta. It's cot theta, but tangent of 90 plus theta, it is minus cot theta. Now let me take up a few questions. Say I have the first question. Say r equal a 1 minus cos theta at theta equal to, say 0. I have to find that angle between, question is find the angle between the tangent and the radius vector. Fine. Okay. And I know what is the angle between tangent and radius vector. It is r d theta by dr. What I need is that r, this is r, and I need d theta by dr. That can be found from this. So let me differentiate 1 with respect to theta. I will get dr by d theta equal a sine theta. Now tan phi is r d theta by dr is a 1 minus cos theta, and this is a sine theta, because you have dr by theta equal sine theta. This is d theta by dr, so this will be 1 by, so this is it. Now at theta equals 0, what is tan phi? Tan phi is 1 minus cos 0 sine 0. It is 0 by, sine 0 is 0, cos 0 is 1. So this is 0 by 0 form, so indeterminate form. If I will take same question, but I will take 1 minus cos theta at theta equal pi by 2. Okay, then dr by d theta is same, a sine theta. Tan phi is r d theta by dr is a 1 minus cos theta by a sine theta. Now at theta equal pi by 2, what is tan phi? 1 minus cos pi by 2 sine pi by 2. Cos pi by 2 is 0, it is 1 by, sine pi by 2 is 0, it is 1. So tan phi is tan pi by 4. So our phi is pi by 4. So angle between the tangent and radius vector is pi by 4. Similarly, for r square equal a square cos 2 theta, let me take this one. R square is a square cos 2 theta. So let me differentiate with respect to theta. 2r dr by d theta is minus 2a square sine 2 theta. So dr by d theta minus a square sine 2 theta by r. Now what is tan phi? Tan phi is r d theta by dr. It is r by minus a square sine 2 theta. So it is r square by minus a square sine 2 theta. Your r square is minus a square cos 2 theta upon minus a square sine 2 theta. So it is minus cot. So tan phi is minus cot of 2 theta. But minus cot can be changed into tan. It is tan 90 plus 2 theta. So your phi is pi by 2 plus 2 theta. So this is angle between the tangent and the radius vector. If now your theta is 0, you will get phi equal to pi by 2. If it is pi by 2, pi by 4, so on. You can find all these angles between radius vector and the tangent at various points, various initial initial angle 0, whether it is pi by 2, whether it is pi by 4, and so on. You can find it. Okay. Next, let me take a few questions from the book. Yeah, r equaled a cosecant square theta by 2 at theta equal to pi by 2. Fine. Okay. You see, let me again find dr by d theta, because I know what is tan phi equal to. This is derivative of cosec square minus 2a cosec theta by 2, then derivative of cosec and cot, so cosec square and cot theta by 2, and derivative of 1 by theta by 2 is 1 by 2. Fine. 2 cosec square is twice a cosec theta by 2, then derivative of cosec minus cosec into cot, so it is cosec square and cot, and derivative of theta by 2 is 1 by 2. So this is dr by d theta. Now what is tan phi? R d theta by dr. This is r. What is r? A cosec square theta by 2. And what is dr by d theta? It is 1 upon minus a cosec square theta by 2 cot theta by 2. So tan phi is minus tan theta by 2. But minus tan can be written in terms of tangent of pi minus theta by 2. So your phi, angle between radius vector and tangent, is pi minus theta by 2. But what is your theta? It is pi by 2. So it is pi minus pi by 4. So it is 3 pi by 4. Angle between tangent and radius vector is this. Okay. Now let me take a question. Find the angle between tangent, sorry, this I have already done. Find the angle of intersection. Intersection between two curves. You know that alpha, phi 1 minus phi 2 or phi 2 minus phi 1. Which one is bigger? Phi 1 is greater than phi 2 or phi 2 is greater than phi 1. Let me again capture that. This is P r theta. This is tangent to the curve, and this is the pole. This is the radius vector. This is angle phi or phi 1. There is one more curve moving from the same point. There will be on this point another tangent, and there will be angle between the radius vector and the tangent. Say that is phi 2. So there is something common, that is known as alpha, the angle of intersection between two curves. This is first curve, this is another curve. Let me take two curves. See, I have r equal a1 minus cos theta and r equal a1 plus cos theta. Fine. This is 1, this is 2. You see, both these curve, angle of intersection, we have to find angle of intersection, they pass through a same point. So at that point, these will be equal on that point. So for that point, from 1 and 2, what I will get? This is r a1 minus cos theta, a r plus, so I will get from 1 and 2, a1 minus cos theta equal a1 plus cos theta. So 1 and 1 goes, so cos theta, 2 cos theta equal to 0. It means cos theta equal to 0 means theta equal to pi by 2. Fine. Again, now you have two curves, r equal to a1 minus cos theta. This is 1. R equal to a1 plus cos theta. This is 2. Let me differentiate with respect to theta. I will get for this curve dr by d theta equal a sine theta. Now tan phi 1 r d theta by dr, a 1 minus cos theta a sine theta. 1 minus cos theta is twice sine square theta by 2. Now sine theta is 2 sine 2 theta by 2. It is twice sine theta by 2 cos theta by 2. So I have tan phi 1 equal tan theta by 2. So phi 1 is equal theta by 2. But what is theta? It is pi by 2. So phi 1 is pi by 4. This is one thing. Now let me find dr by d theta over here. Dr by d theta is minus a sine theta. Tan phi 2 r d theta by dr is a 1 plus cos theta upon minus a sine theta. So this is 1 plus cos theta is twice cos square theta by 2. This is twice sine theta by 2 cos theta by 2. This is cot theta by 2. But what is cot in terms of tan? It is tangent of 90 minus theta by 2. So our phi 2 is pi by 2 minus theta by 2. But what is theta by 2? Theta is pi by 2. So it is pi by 2 minus pi by 4. So this is 2 into 2. It is pi by this is cot. Cot is tan 90 minus theta. Okay, theta is pi by 2. So it is pi by 4. 4 is LCM. 2 into 2 minus pi. So it is pi by 4. Is it okay? Twice sine square twice. This is okay. 5 by this is pi by 4. Now this one is r. This is minus over here. Minus cot. Sorry, this is minus cot. See, you have dr by theta is minus a sine theta. So this will be minus a 1 plus cos and minus sine theta. So this will be minus cot. So minus cot is tan pi by 2 plus. So pi by 2 plus. So this is 2 into 2, 3 pi by 4. So which one is bigger? Phi 2 is bigger. So alpha is phi 2 minus phi 1. It is 3 pi by 4 minus pi by 4. 2 pi by 4, which is pi by 2. So alpha is also pi by 2. So for these two curves, you can find theta, you can find angle of intersection. I will take a few, I will note down some few exercises. You have to do it at your home. Questions are, you have to find angle of intersection. Say r equal to a 1 plus sine theta, theta equal to pi by 4. Then you have to find angle of intersection. R equal to a theta. You have two curves and r equal to a by theta. This is one. Okay. Then you have r equal to a cos theta and r equal to a1 minus cos theta. Then you can have one more question. say r square equal a square cos 2 theta and r equal a 1 plus cos theta. For these, find alpha. For this, find phi. This is it. Thank you.